Coulomb's law of magnetic force. Okay, we have seen in electrostatic about the force which exists between 2 point charges in free space. Now, if Q1 and Q2, they are the point charges present in free space at a distance r between them, then the force of attraction or the force of repulsion between these 2 point charges is given as 1 upon 4 pi epsilon naught Q1 Q2 upon r square. Okay, so in a similar way, right, if you want to determine about the magnetic force between 2 poles of a magnet, then in place of Q1 I will write Qm1, in place of Q2 I will write Qm2, which means because these charges Q1 and Q2, they may be like charges, which mean both are positive or negative, or they may be unlike charges in which one is negative, another is positive. So similarly, in this case, I will say that these poles, it may be like poles or unlike poles. When I say like poles, it may be, right, both are north poles or both are south pole. And if they are unlike poles, then one is a south pole, another is a north pole. Okay, so we will just follow from this equation, right, to find out the Coulomb's law or the Coulomb's force between 2 poles of a magnet. Okay, so for that, look here. When these 2 poles are having a pole strength Q1, Qm1 and Qm2 at the distance r in free space, then the magnetic force between the 2 poles will be equals to mu naught upon 4 pi Qm1 Qm2 upon r square. So what is the difference? The difference is just this constant. In electrostatic, we have 1 over 4 pi epsilon naught. In this magnetostatic, we have mu naught upon 4 pi. Epsilon naught is the permittivity of free space, and mu naught is known as the permeability of free space. The value of 1 upon 4 pi is equals to, the value of 1 upon 4 pi epsilon naught is equals to 9 into 10 to the power 9 Newton meter square per Coulomb square. But the value of mu naught upon 4 pi is equals to 4 pi times 10 to the power minus 7 Henry per meter. Alright, so these are the interrelations between the electrostatic and the magnetostatic. Okay, alright, so now if this Qm1 is equals to Qm2 is equals to 1 unit, that means the 2 poles, right, they are at a distance of 1 unit. They are 1 unit each, and they are placed at a distance, let's say, of 1 unit. In that case, r is equals to 1. So then, what will happen to this Fm? So the magnetic force between the 2 poles will become mu naught upon 4 pi times Qm1, Qm2 is equals to how much? Is equals to 1 each. And this r square means 1 square. So Fn, it is equals to just mu naught upon 4 pi. But this value mu naught upon 4 pi, it is equals to 4 pi, okay, sorry, this is just mu naught only, okay. So this mu naught, the value of mu naught is equals to 4 pi into 10 to the power minus 7, and the value of, okay, when you substitute the value of mu naught over here, then you will get 4 pi into 10 to the power minus 7 upon 4 pi. Okay, so this 4 pi with 4 pi cancel, so you will get, I will write it here, Fm is equals to 10 to the power minus 7 Newton. Okay. So, see, I have considered that the poles, right, is equals to 1 unit. So I can see here that these pole or a unit pole right? Is defined as, when, or I will say this, the poles are said to be 1 unit if they are placed at a distance of 1 meter each, and they will experience a force of attraction or repulsion between them 10 to the power minus 7 meter. Okay, so this is how we obtain Coulomb's law of magnetic force by just following it from the Coulomb's law of electrostatics.